So we're going to conclude this section on 5-number summary and box plot by comparing, first of all, comparing box plots and histograms. So based on histograms, what does a box plot look like? And then sort of going backwards, if you see a box plot, what would you anticipate the histogram to look like? These first two are histograms with many, many classes, no gaps or anything like that. We know what's supposed to happen with the median and the quartiles. We're supposed to divide the area into 4 equal-sized pieces. It's pretty hard to draw that. I tried as hard as I could. So the median, if it's symmetric, the median is in the middle. That divides the area in half. If it's not symmetric, it's a little bit harder to see how to get the areas to match. I tried pretty hard. And then in each of the halves, you've got to divide them in half. And the tendency is not to do it too well, so I probably obeyed my tendency. This probably belongs just a tiny bit over to the right. It's a little hard to see how to do it, maybe here. Divide that area into 2 equal pieces. And then we would carry these down. These would be the positions of the quartiles. Here's the median, here's the max, here's the min. There's the box plot that goes with it. Same thing here. So seeing a box plot infers something like that for the shape of the histogram. But it's not perfect. That doesn't necessarily mean the histogram is symmetric. It just, that's where the quartiles are. There could be things that are going on that are all wonky in there to mess it up. And here's a little more jaggy stuff down here. Here's a histogram down here, skewed to the right. Now when you divide the area up into equal-sized slices, it's a lot harder to do. Probably messed it up a little bit, but the idea is good. We carry down the positions where we've cut the area into 4 pieces down to the median and the quartiles of the max and min. So you get a box plot that looks something like that. And that same story here, carry these down. And that's what the box plot should look like. So if you see a symmetric box plot, it's likely the histogram is roughly symmetric. You see one where the right-hand side has longer arms on it like that, and ordinarily sometimes you'll see it look like this, short on this side, and this will get even longer, so even this middle box is longer on that side, and then like that when it's skewed to the right. So, okay, so that's sort of interesting. Over here, we'll see one of the main reasons we make box plots, and that's to make a quick comparison between data sets. So here we have Canadian births, I think it's Canadian, say Canadian? Canadian births per day of the week throughout the year. So I suppose there's 52 values, 52 numbers. Each one of them is the number of births, 52 numbers? Every Monday for 52 Mondays, you collect the values, and this is what it looks like every Tuesday for 52 Tuesdays. So there's between 500 and 400 births on Tuesday for every Tuesday throughout the year. A lot of babies. And that, since you don't get the same number on every Monday, you have a distribution of values on Monday. So Monday you could have as much as maybe 540 and down as much as maybe 360, and somewhere in the middle, it's like 425 is the number of births. And you carry that forward throughout all the days of the week, and you see, hang on, there seems to be a pattern here that Monday through Friday, looks like it's more. Looks like it less. So you might wonder why fewer births on Saturday and Sunday and more on Monday, Tuesday, Wednesday, Friday overall. It's not a huge amount, but it looks like a consistent pattern. When I look at it on here on the handout, it looks more obvious than my drawing. I tried to copy it as best I could. It's pretty obvious that Saturday and Sunday numbers are less than Monday through Friday, but it looks like Monday through Friday numbers, maybe there's not a pattern there. That just could be something random. So think about it for a while. Why would there be fewer births on the weekend? Students say, well, people are more relaxed on the weekend, so they don't give birth. They say they're not working that day, they don't want to give birth on that day, they'd rather give birth on a work day. Oh, pick a lot of things. But I think bottom line probably is a lot of births are induced. And the doctors don't like working on the weekends. So these births that happen, some of the births that happen Monday through Friday are induced births. And if it wasn't for births being induced during the week and not on the weekends, we'd see more or less the same number of births every day of the week. That's my take on it. But the take on it is not as important as noticing that you can use the box plots side by side on the same scale to compare various groups and decide whether some of them consistently have larger values or smaller values, or consistently have more spread or less spread. If you did this year after year and you found out that Monday has more spread than Wednesday, it just keeps happening, you could analyze that question. Why is that going on? In that vein, we have this mileage distribution by type and origin, which I'm not going to attempt to reproduce, just to show you where things could be if you have a very complicated question and you're just trying to do exploratory data analysis. Those are all modified box plots, so the little zeros on there are outliers, and you can take from this what you want. It says, what could you conclude from this graph? Heaven knows. The Asian cars are the red ones. They tend to be generally larger in value than either the blue ones or the other blue ones. Haha, one's Europe, one's the US. So that's what I take out of it. And then you might wonder what they mean by wagon. This must be old data. Maybe station wagon? I'm thinking station wagon. You might look to see that there seems to be a lot more variability in Asian vehicle mileage. Those middle boxes tend to be a lot bigger, and the spread overall tends to be larger, and the values tend to be higher on average. And conceivably what's going on there, since mileage has a lot to do with the weight of the vehicle, maybe there's a lot more variability in vehicle weights in Asian cars than, say, in American cars or European cars at the time they were doing this analysis. I would wonder, with the guy that has, you see one there, sedan, 38 miles per gallon. Maybe those were the first hybrid cars made. It says, I don't know if that's US or not. I can't tell by the, it looks like it's European. So that could be just one of those midget cars they started making in Europe years ago. Maybe the two-seaters that they had out there that got 35, 40 miles to the gallon. I don't know. So you can look at it and see things. You can hypothesize things, but you'd have to look deeper into the data. So the purpose of side-by-side box plots is to give you some ideas of what you might try to explore in terms of the data. So you see something that seems to be going on, and then you can look deeper for what the cause is and find out exactly why you see certain patterns possibly. And without the box plots, you wouldn't know what patterns to hunt for. So that ends our 5-number summary and box plot situation. And we'll see what's coming next any minute now. For me, hopefully, maybe it's more videos tomorrow. It's getting late in the day. We'll see you later.